Okay, for the last video, we already discussed about rate law or rate equation, how to determine the order of reaction. We already discussed differential rate equation. So it's a connection between rate disappearance of reactant with rate appearance of product. So the last part is integrated rate equation. So integrated rate equation can be divided into three different equations. So for zero order, first order, and second order. So this is the rate law for for zero order. So this is for the first order. So this is for the second order. So unit of K is depending on order of reaction. So this is the unit of K. Okay. So when Y equals to mx plus c, so when we plot the graph rate versus with concentration of A, it is constant because concentration of A is independent towards rate of reaction for zero order. Okay, so for this first one is rate, okay, graph of rate versus with concentration of A, so it's directly proportional, and then the C is start from 0. Okay, the intercept Y is start for origin. Okay, so the last one, Y equals to mx plus c. So the graph is rate over concentration A squared. So similar with this one, it start from origin because there is no expression of C. So the slope is K. Okay, so this is the graph of rate versus with concentration. Okay, so the integrated rate law for zero order is this one. So A naught means initial concentration. So this is the initial concentration. Okay, for example, after 2 minutes. After 2 minutes, so after 2 minutes, this is the remaining. So this is the remaining concentration. So concentration of this one is referring to this time. So initially I have 0.2. After 2 minutes, the concentration of reactant is decreasing to 0.1, for example. Okay, so concentration of A here is remaining depending on time here. Okay, dia yang remain bukan decompose. Decompose maksudnya yang hilang. Yang bertukar jadi produk itu decompose. Remaining yang tinggal. Initially ada 0.2, lepas 2 minit tinggal 0.15. So 0.15 yang tinggal. Daripada 0.2 yang decompose adalah 0.05. So again katakanlah initial adalah 0.2. After 2 minutes yang tinggal, yang remain adalah 0.15. So yang decompose, yang decompose adalah 0.05. So here adalah remaining, bukan yang decompose. So when you read the question, you need to carefully understand the question. So whatever remain here is depending on time here. Okay, same goes to this one. So for the first order, ln, so this is ln, okay, not log. Ln concentration of A, the remain A, equal to negative KT plus with ln concentration A initial. So the last one is 1 over A equal to KT plus with 1 over concentration A at initial state. Okay, so from this equation, you can plot a graph. So you get graph something like this. Okay, and then the last one, so you need to memorize this equation, integrated rate equation for zero order, first order and second order. You need to memorize. Okay, and then the last formula that you need to memorize is half-life. What does it mean by half-life? Half-life is time required for the initial concentration to become half. Okay, the concentration of reactant to fall to half from its initial value. So the time taken for the initial concentration to become half. Okay, for example, 0.2 is the initial. So what is the time taken to become 0.1? So we call that time as half-life. We call that time as half-life. So the equation for half-life is different for 0, first and second. So you need to memorize this one as well.